So this module is going to build on Module 3, focusing on vector data. And in this case, we're going to work more on creating vector data and the cases when we might want to build these things from scratch as opposed to downloading them from a pre-existing source. So to start off with, there are different cases where we might want to import or create point data versus polyline data versus polygon data. Now for point data, this could be things like digitizing off of a printed map where we might have, say, spot elevations across a topographic map, and we wanted to be able to record where the high and low places are from the scanned map. So we would simply go through, click on each one of these if the map's already been georeferenced, and then suddenly we have a new layer that we can enter those values in and end up with a new polygon or point shapefile that has those high and low elevation points. We could also do things like find particular locations from satellite imagery if we wanted to find the locations of cities or particular buildings and create new features there to be able to query about where they are in relation to each other, in relation to other features. We can create point shapefile or point data from GPS units as well, both from importing these directly into the computer or by manually entering them by simply entering the X and Y coordinates as we've sort of jotted down from our GPS, or by bulk importing them from a table as well. We're going to work with bulk importing a tabular data structure that has latitude and longitude in it in a later demonstration when we're dealing with tables and databases. But the process is relatively simple to import these from tabular data. Now with polyline data, we might do things, again, like digitizing a printed map. If we had contour lines, we might want to go through and digitize all of the contour lines so we can understand the topography of that region a little bit better. This does assume that the map has already been georeferenced. And we would simply trace these when we're creating a polyline shapefile like this, where we start clicking, we follow it around, and then double click to end. And then we could have a new vector data layer that was all of these polylines. We can also use GPS-created data to create polyline features. In this case, it's usually what's called a track log, where the GPS is taking a certain number of points a minute that shows where we've gone during the time that it's been turned on or been set to do this. As for polygon data, these are not as commonly recorded directly from GPS units, but often we do them from digitized maps of some form or from satellite imagery. And the one we're going to work with in the demonstration is a soil map, something that covers the entire region that we'll be working with for the sample data. And we need to go through and actually take that scanned map and turn it into something that we can query the vector data, and we can have all of the information about that soil type associated with it in the data table. So it's a simple process of tracing, where we're going to trace each one of these and create polygon features that represent each one of the soils. We can then symbolize them in different ways, show the area, show different colors, label them. We don't have to do something that covers the entire region like this. We could also simply do locations of particular things that are not necessarily just points. So if we wanted the footprints of buildings, if we wanted the locations of sort of the area of a crop field or a forest type or a archaeological site or something like that. Now the process of editing vectors in ArcMap, in ArcGIS, is not particularly complicated, though it does have some very distinct steps. So I want to go through each one of these steps before we're doing it in the demonstration, just so that we all understand what the whole process is. The very, very first thing we have to do, assuming we've already gotten the map that we want to digitize scanned, or we've already downloaded whatever imagery it is we're going to work off of, is we need to create a shapefile to hold the features that we're going to be creating. So the first thing we have to do is decide whether we're going to be working with points, polylines, or polygons. This has to be done in advance. Just to review things that we talked about in Module 3, point files are made up of individual points. Polyline files are made up of a series of vertices with a sort of start and stop point. And polygons are of a series of vertices with lines that then define a polygon. And that polygon can be very complicated as well. It could have a donut hole in the middle of it. It could be two separate parts. So there's lots of leeway within there, but we just have to be sure that we are deciding which one of these different geometries we want to work with. Now the second stage is adding fields to our attribute table, so creating the place in the attribute table where we're going to store the data. We'll discuss this in a little bit more detail in the following module on tables and databases, but in this early stage we just need to be sure that we're creating the proper type of field to store the data that we want. For the demonstration this week, or in this module, we're going to be working with soil maps. So we're going to create a field that is going to store the code for that particular soil. We do have multiple different options in there. We could use short integers or long integers. These are numeric, things that don't have a decimal place, and short and long refers to just the length of it, whether it's greater or less than 32,000 or not. We also could do decimal place ones. These are what we call float and double. They're really just referring to the number of digits in there, whether it's before or after the decimal place. Then we can have text and we can have dates as well. We're going to create a text one in the demonstration this week to store those soil codes. Now, whenever we're creating these things, it's going to ask us something about the precision and scale, particularly for numeric things. For text, it's going to ask us the length of the field. When we're dealing with precision and scale, this is essentially the maximum number of digits is the precision that can be stored, and the scale is the number of decimal places for float and double types. Really, if we leave 0 for either one of them, it's going to default to the maximum. So the next thing we want to do, step 3, is going to be to create an editing, or to begin an editing session in ArcMap and begin to choose our settings. Now, ArcGIS ArcMap is a little bit strange about how it works with editing. We have to be actively have started an editing session to be able to change anything about our shapefiles. And this is very much on purpose because it keeps us from doing anything accidentally. Once we've started this editing session, we can't add new fields, we can't do anything else. We can only edit geometry, and we can only add attribute data to pre-existing fields. And this is because it creates a temporary version of the file so we can go back if we need to. Now, one thing that you'll notice very quickly when you start editing is something called snapping. And this is going to be where the cursor jumps to pre-existing vertices or pre-existing features in different layers. By default, it's turned on. If you need to, you can turn it off in the editing toolbar. Now the next step, step 4, is going to be to begin digitizing the map, so creating new features. For points, this is either by clicking or manually entering the coordinates, though we can also move existing things around. For polylines, we would start clicking, and then we would single click along the entire feature until we got to the end, and then double click to end it. For polygons, it's a little bit more complicated. We're going to start with a single click, and then as we go around, it's going to be automatically kind of closing it for us until we reach the end and double click. So this will become apparent when we start working with it in the demonstrations a little bit better. But there is one other kind of additional issue with polygons that's going to become important while we're working with these soil maps. And that's when you're making polygons that cover the entire area, you don't want to retrace the same spot multiple times. So if you have one that's sort of next to another, you want to keep that same edge exactly the same. You don't want to try to retrace it yourself because inevitably you'll make small little mistakes. You won't hit every single vertex exactly the same way, and you'll end up with some problems in there. So there are two different ways we can do this, either by sort of copying over the known edge, so what's called an autocomplete polygon, where it's going to keep that same edge, use that same edge the same way, or we can create one big feature and then kind of cut it in two. And I'm going to show you how to do both of these, and then we'll do both of them during the demonstration as well. So the first way to do this autocomplete way, is what we call by accretion, where we're going to begin by drawing the largest polygon we can find and then sort of building others onto it, using these autocomplete polygon tools to sort of build out and keep exactly the same edges. And if we have any island polygons, if we have one that's completely within another one, we have to use another tool. We have to cut it out of the original one using the cut tool. So it'll look sort of like this, where we build our first polygon, finish it, and then to do the autocomplete, we start within the pre-existing one, or any pre-existing one, follow the new edge, and then when we get to the end of it, we go back within a pre-existing one. We're not trying to retrace edges in there anywhere. The other way to do it is by deletion. This is equally functional. Really, there's not any significant difference between them other than once you start with one, you're pretty much locked in for the rest of the digitization process. And in this case, we would start off by creating a polygon of the entire area, and then we would simply cut out pieces, cut it out into increasingly smaller pieces, and begin to add the data about those features into the attribute table as we worked along. So it would look something like this, where we create one big area and then begin to cut off pieces so that we end up with different polygons representing the different soil types. So that's a little bit about vector editing, creating vector data, when you might want to use it in the different types. And we're going to follow this with the next module where we actually begin to work a little bit more directly with the tables and databases of the attribute data.